Well, hey, AP Bio students, it is Mrs. Shelton coming to you live from my living room. It's spring break, and like all good spring break AP Bio teachers who are on home quarantine for COVID-19, we're just going to have a party talking about AP Bio math because my jalapeno poppers aren't ready yet, and my daughter Sydney decided to bring out her karaoke machine. So, let me introduce you to my daughters who are highly distracting. Oh, they don't want to be on camera. They just want to give me cool disco lights. So that's what we got. There's Sammy, and there's Sydney. There she is. She is responsible for the disco light presentation that we are going to have now. But today, just super fast, we are talking about this worksheet here, rate and growth and everything else worksheet is what we're going to address. So this is from this particular presentation, which this is also then from page 2, the second side of this AP Bio equations and formula sheet that you guys are going to get. So don't you guys just want to come and party at Mrs. Shelton's house and do more math? So let's do it. Now, for today, when you take a look at, I can't see my screen. Where's F5? I can't see it. Present. There we go. Like I said, this is page 2 of Appendix A. I call this rate and growth and everything else. You guys will see that this is your equation sheet where it's rate and growth. And really, of these, if we take a look at these equations here, you will definitely see rate and be expected to understand rate. But a lot of these other ones, population growth, exponential growth, logistic growth, primary productivity, those actually came in Unit 7, Unit 8. So I do not expect to see those on this year's test. I do expect potentially water potential to show up there and recognize all the information that the equation sheet gives you for water potential. And then the equation sheet also gives you surface area and volume equations in case you need to calculate that. So you also have some concentration, and you also have Gibbs free energy, and then you also have your pH understanding as well. So let's just take a look really quickly at some of the things that you'll need to do. You will find that this worksheet is much easier than the previous one because it's all stuff that you've done before, and it's plug and chug, and you can do it. Now, rate, absolutely positively know how to calculate rate. Rate is your slope of the line. It's your change in the y-axis divided by your change in the x-axis, and always pay attention to where they're asking you to calculate rate from which data points are they asking you to calculate. So know how to do that, and know how to also include your units in the end, which your units are always going to be whatever the y-axis unit is over time. Your x is going to be your time axis. Population growth, you guys are going to have to do a sample problem population growth, which that is birth rate minus death rate. So in that particular type, that's all very logical. And recognize exponential growth. You do have an equation for exponential growth, but you should be recognizing an exponential growth curve versus then a logistic growth curve. So that's where I had you guys draw that as far as this J-shaped curve versus this S, and recognize though that carrying capacity. So there's a rate problem for you. Make sure you guys do that. There's a population growth problem for you to do that. There's a productivity problem for you guys to do as well. Again, productivity was going to be part of Unit 8, so doubtful that that's going to be anything that is asked of you. Here, though, is a potential problem they may ask because not a lot of students ever do this, and it's a Q10 factor. This is a simple plug and chug problem. It's a factor in which a rate of reaction will increase when the temperature is raised 10 degrees. That's defined for you on your equation sheet. And so just do that one sample problem here in order to understand what a Q10 value is. So there is a sample problem for you and a solution. We did lots of surface area to volume ratios when it comes to efficiency of a cell, because remember that surface area is representing the cell membrane as far as movement of materials in and out. So that might be a calculation you were asked to address as well. But recognize those equations are given to you. And then also when we studied energetics, we did talk about delta G and remembering our spontaneous and our non-spontaneous reactions, but you are also given your Gibbs free energy equation here. So I ask you to do some sample problems with Gibbs free energy just to become familiar with it. Remember, in calculating water potential, water potential is definitely something that you might expect. This is when we talked about your cell membrane. Calculating your water potential, remember it's a sum of pressure potential and solute potential. And then you also have an equation for plugging and chugging to calculate that solute potential. Remember that pressure potential in an open container is always 0. So if they ask you to calculate water potential in an open container and then they tell you the solute is glucose or they tell you the solute is sodium chloride, then you're going to know what your ionization constant is. So practice those practice problems. Make sure you are remembering your pH and how to calculate pH. If I gave you your hydrogen ion concentration, then you're going to know that it's the exponent, -5. And also remember here that your hydroxide plus your hydrogen ion concentrations, if I add these up, they total up to 14. So this is how I understand my relationship with my pH. Here's a dilution in case that's ever asked. I've never seen it asked ever before, but do the practice problems. We will have a Zoom meeting at some point to answer any questions. I have provided you all of my solutions. And my jalapeno poppers are about ready to be done. My disco party math party for spring break is about to begin. And I hope you guys are having just as much fun as I am on my spring break. So with that, this is Shelton, the AP Biomath. It's tons of fun. See ya. Miss you. Bye.